everybody, welcome to our 11.4 notes, part 3. We're starting with example 4, where we are solving a radical equation that reduces to a quadratic equation. So this should be a refresher from chapter 10. To undo a square root, you should be squaring both sides. So what's going to happen on the left side if you square everything is the square root and the squaring will undo each other, and you're just left with an m plus 1 on the left side. On the right side, when you square all of that, you don't just get to square each term individually, you have to square the whole thing, which means distributing. So what that's going to look like is negative 1 plus the square root of 2m times negative 1 plus the square root of 2m. And then we need to distribute. Negative 1 times negative 1 is positive 1. Negative 1 times the square root of 2m would be negative square root of 2m. The square root of 2m times negative 1 is the negative square root of 2m. And the square root of 2m times the square root of 2m is a positive square root of 2m, the whole thing squared. So then that squaring and square rooting are going to undo each other. You're just left with 2m over there. Then we've got some like terms with our radicals in the middle. And the negative 2m, square root of 2m minus square root of 2m would be negative 2 square root of 2m. I still have everything else, so I'll just bring them down. So I'll have 1 minus 2 square root of 2m plus 2m equals m plus 1. At this point, I do want to get rid of my other square root, which means I need to isolate it. I need to get it by itself. To do that, I'm going to subtract 2m from both sides, and I'm going to subtract 1 from both sides, just to get that by itself. So 1 minus 1 will cancel, 2 minus 2m cancels out. On the right side, I'm left with negative 2 square root of 2m. On the left side, m minus 2m would be negative m. 1 minus 1 is 0, so I just have negative m on the left side. Last but not least, to get that square root by itself, I'll divide both sides by negative 2. Negative m divided by negative 2, well, a negative divided by a negative is a positive, so I'll have positive m over 2. On the right side, negative 2 divided by negative 2 is 1, so I'll just have the square root of 2m. Now my square root's by itself, so to get rid of the square root, I'm going to square both sides. M over 2 squared would be m squared over 2 squared, which is 4. On the right side, the square root and the squaring will undo each other. You're just left with a 2m there. At this point, I know that I have a quadratic because I have an m squared, so we are going to have to do something with quadratics at this point. If it makes you feel a little bit better to not have fractions, we can multiply both sides by 4 and make it look a little bit nicer and neater. So on the left side, the 4's will divide out, and you're just left with m squared. On the right side, 2m times 4 is 8m. In case you're wondering, can I divide out the m's because they both have an m? No, because you'll get rid of a solution doing that, and you don't want to get rid of possible answers, okay? We'll check our answers to see if they work or not. You don't want to get rid of them too early. So what we're going to do instead is get it in standard form, which means let's get everything on one side, by subtracting 8m from both sides. I'll have m squared minus 8m equals 0. It actually factors really nicely because it has a GCF. They both have an m in common, so we can factor out the m. So I would have m times m minus 8 equals 0. My two factors are m and m minus 8. So I'll have m equals 0, or m minus 8 equals 0, which means m would be 8. If you remember from chapter 10, with any kind of these radical equations, we need to check our answers. So we need to check both of these and make sure they actually work. So how about we check m equals 0 first? If I plug that into the original equation, I'll have the square root of 0 plus 1, which would just be 1, equals negative 1 plus the square root of 2 times 0. So 2 times 0 is 0. The square root of 1 is 1. And the square root of 0 is 0. So I have 1 equals negative 1 plus 0. Does 1 equal negative 1 plus 0? No, it doesn't. 1 does not equal negative 1. So m equals 0 is not an answer for us. Let's check m equals 8. So if I substitute 8 back in, make sure that works. On the left side, I have the square root of m plus 1. So that would be the square root of 8 plus 1, which is 9. Equals, on the right side, negative 1 plus the square root of 2m. Well, 2 times 8 is 16. The square root of 9 is 3. And the square root of 16 is 4. So I have, is 3 equal to negative 1 plus 4? Yes. Yes, it is. So that answer works. And so we only have one answer for this one. It's m equals 8. You certainly can get 2 answers or no answers, but you do need to check them with the radical equations. All right, last thing that we're going to do is solve equations that are quadratic in form. So all of these equations are not quadratics, but they act like them, and so we can solve them with the same methods. So the first one we have in example A is 9x to the 4th minus 37x squared plus 4 equals 0. In this one, what you notice is my middle term, instead of having an x, it has an x squared. In my first term, instead of having an x squared, I have an x to the 4th. But x to the 4th is x squared squared. So essentially what we have is, instead of having x's in this one, we have x squareds. So I'll make you a little note over here that instead of x's, it's x squared in this problem. But otherwise, it solves the same way. This one actually factors pretty nicely, so how about we start with that? To get 9x to the 4th, we're looking at either 9 and 9, or 9 and 1, or 3 and 3. I'll go ahead and save you guys a little bit of work. 9 and 1 is going to be the one that works, okay? So we'll have 9 and 1. To get the x to the 4th, it's x squared and x squared. Because x squared times x squared is x to the 4th. And then that way you're going to get a middle term that has only x squareds in it. You don't want x cubes and x's. That's not going to give you an x squared. To multiply to equal positive 4, that positive tells me that it's the same signs, and the middle sign of a negative means that we're going to have subtraction here. To get 4, we're either looking at 2 and 2 or 4 and 1. I can tell you right now it's not going to be 2 and 2, because that would give me a lot of even things and not a 37, which is odd. So we're looking at 4 and 1 instead, and actually it ends up being 1 and 4, because negative 36 squared plus negative 1x squared is negative 37x squared. From here, we can actually keep going because we have perfect squares minus perfect squares. We have a difference of 2 squares in each of our parentheses. So we can keep going. In the first one, 9x squared minus 1 factors as 3x plus 1 and 3x minus 1. In the second one, x squared minus 4 factors as x plus 2 and x minus 2. And you'll notice we're going to get 4 answers. And I could have told you that at the beginning because it's x to the 4th. My highest exponent is a 4, so I'm going to have 4 answers, and that's okay. So my factors, my first factor is 3x plus 1. So if 3x plus 1 equals 0, then x would be negative 1/3. My second factor is 3x minus 1. So to solve for that one, I would add 1 and divide by 3 and get x is positive 1/3. For x plus 2 equals 0, I would subtract 2 from both sides and get x is negative 2. And for the last one, my last factor is x minus 2, and if x minus 2 equals 0, then x would equal positive 2. So I actually have 4 answers here. I have x equals negative 1/3, positive 1/3, negative 2, or positive 2. let's look at another one. In part B, I have 4x to the 2/3 equals 3x to the 1/3 plus 1. And so this one, first off, it's not in standard form at all, because everything's not on the same side. So how about we work on that first, and then we'll look at what we have. So I'm going to go ahead and subtract the 3x to the 1/3 from both sides and subtract 1 from both sides. Then I'll have 4x to the 2/3 minus 3x to the 1/3 minus 1 equals 0. So for this one, instead of x's, I have x to the 1/3. For those of you who really don't want to work with x to the 1/3, we can use the trick of substitution if it helps, okay? So how about instead of x to the 1/3, let's just say that y equals x to the 1/3 and use some substitution, okay? So x to the 2/3 is actually x to the 1/3 squared because it's twice that exponent. So this would be the same as 4y squared. And we're saying that y is x to the 1/3, so in the middle that would be minus 3y. And that may look a little bit better for some of you, okay? When you're solving for the x, we will have to go back, just to let you know. But you can do this as a middle step if it helps you. Okay? It does factor pretty nicely, so let's do it. To get 4y squared, we're going to have 4y and 1y. To get -1, we're going to have a +1 times a -1 to get there. And -4y plus +1y equals -3y, so it's factored nicely. And then you're going to get two answers. From our first factor, 4y plus 1 equals 0. I'm going to get -1/4. For a second one, y minus 1 equals 0, I would have y equals 1. Now we're not done because we solved for y, but we wanted to solve for x. So what we're going to do with both of these is actually put it back into this little equation that we had up here that started our substitution to begin with. So let's go ahead and do each one by itself. So how about we start with 1 because that's a nice pretty easy number, okay? So I'm going to just start with 1. So if y is 1 and I need to solve for x, the x to the 1/3, that's the same thing as the cube root of x, if that makes your brain a little bit happier. And the opposite of the cube root is cubing. And whatever you do to one side, we need to do to both sides. If you like working with the exponents, you can also just think 1/3 times 3 equals 1. And so then you're just going to have x on the right side. 1 to the 3rd power is 1. So there's one answer for us. With the -1/4, I'll have -1/4 equals x to the 1/3 power. We're going to do the same thing. We'll cube both sides so that we can solve for x. So I'm raising it to the 3rd power. So then we have x on the right side. -1/4 to the 3rd would be -1/64. And there's my two answers. The last one looks a little bit frightening, but don't let it scare you. Our denominators are 2p plus 2 and 2p plus 2 squared. So my LCD would be 2p plus 2 squared. So if I multiply everything by 2p plus 2 squared, I'm going to have 3 times 2p plus 2 squared minus 7 times 2p plus 2 equals 6. And I'll go ahead and subtract the 6 over so I'm in standard form. This time, instead of having x's, you've got 2p plus 2. So make your y equal to 2p plus 2 and substitute. And I'm going to let you guys try this one, okay? So try doing your substitution. I promise I'll give you the answer in 3, 2, 1. All right. When you finish, you're going to get p equals -4/3 or p equals 1/2. Before that, if it helps, you're going to get y equals -2/3 or y equals 3.